Hello everyone, welcome back to another exciting chemistry video lessons. Now in this particular video, I'm going to be explaining to you a particular question that a student sent to me uh, from a far country, right? Now the question is right here on the board, and the question says, which of the following complexes is likely to be colored? Which of the following complexes is likely to be colored? Now, these are complexes, so we're going to be indicating which of them are colored. Now, in this particular video, I will do just two for you and explain. Then you will do the rest and tell me your own answer in the comment section below. And at the same time, we also offer online tutoring via Zoom, a live class actually, whereby we brood students, we make them to be a pro and a master in sciences, be it chemistry for undergraduates, for colleges, for high schools, for just anything that to do with chemistry, sciences, STEM, computer, mathematics, algebra, all we offer it, and we give you the best with affordable fee. So let's go. Now this question right now, I'm going to be picking this first one for you, which is something here, right? So this is what we call hexa aqua scandium 0. Hexa aqua. Now I did previous video on how to be able to name complexes. So you can do yourself good by going to my previous video, and or you can send me a DM. Actually, these are my contacts. This is my WhatsApp contact, but this can also be my calling line. Also, this one, my calling line. So you can also call me to send it to tell you more about it. Now, I put this stuff here. This stuff you are feeling OH2 is same as H2O. So don't get it twisted. It's actually easy. So what do we do first of all? Now take note. For a complex to be colored, remember in my previous video I said it is from D1 to D9. That's all actually. So we come here to say water is a neutral molecule. So scandium 0 times 6 is 0. So yes, it's also equal to 0. So I come here to say scandium, which is 21, as the atomic number. I write the configuration for scandium. Here will tell me what here will be 1s2, 2s2, 2p6, 3s2, right? Okay, 3s2. Then here is 3p6, 4s2, 3d1. Is that clear now? 3d1. Actually very simple. Now remember, I have already indicated earlier, since there is a 3d1 here, since there's an electron here in the d orbital, which is starting from, which is 1, so we can as well say that this complex, right, is colored. Now to prove it further, we can use what we call the octahedral splitting, the crystal field splitting for octahedral. Now I'm going to be rubbing some part here to actually explain that to you. Please take note of it. Let me just give you a rough work here. Now, according to the octahedral field splitting, I'm having the d orbital here, which is 1, 2, 3, 4, 5. The d orbital has 5 degenerate orbitals, right? So if here is d1, right? So I come here. Here we split to give me Eg 1, 2, 3. Here we split to give me what now? The T2G, right? Now take note. If I'm having 1 here, right? This is what it like. This one can jump. That is what forms colored. So since there is 1 here, of course, it is what now? A colored what? Complex. Exactly. And this is actually very simple. So we quickly move to the next one. Let me do to erase the board. Please take note of it. let me move to that of the question 2. I'll do for that of this copper here. See, this one is more complex. This one is called tetraene dichlorocopper 2 ion. I'll prove it for you here. I'm having this complex here. It's NH3. This is Cl. This is 2. Now take note. Here is 0. 0 times 4 is 0. Chlorine is -1. -1 times 2 is -2. So copper here is -2 equal to 0. So copper here is +2. So that copper is 2 plus. So if I'm to write the configuration for copper to be 1s2, 2s2, 2p6, 3s2, 3p6, 4x1, 3d10, right? 3d10. Now, because there is a removal of 2 electrons here, there will be a removal of an electron from the x orbital and also from what now? The d orbital here. Remember, if you remove 1 electron from here, they become 3d9. So if I'm to do the octahedral splitting for 9 here, there will be 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm trying to prove it for that. So I come in here is for 1, 2, 3, 4, 5, 6, 7, 8, 9. What I just did for now is for high spin. For high spin, we have what we call the octahedral field splitting for high spin and low spin. For high spin, this is how it is. But I was doing for low spin, for example. Let me do for low spin. For low spin, here there will be 1, 2, 3. Before I will fill this up here, I will first of all complete down here first. 3, it's 4, 5, 6, 7, 8, 9. You see now, this is for high spin where I fill here 1, 1, 1, then I move up. While for low spin, I'll fill here 1, 2, 3. I will have to complete down here first before I move up. This is for low spin, this is for high spin. Is that clear now? Now, first of all, without going through stress, because I'm having 9 here, and it tells me from D1 to D9 is colored. That is actually very easy, right? So please do well to do for me this, and send me your answer at the comment section below. Thank you, and God bless you. Kudos, guys.